Maximizing utility subject to a constraint using calculus. The individual choice of garnishment of a burger can be an important point to the consumer in this day when individualism is an increasingly important thing to the people. Donald N. Smith, president of Burger King. We have just shown how to use a graphical approach to determine which affordable bundle gives the consumer the highest possible level of utility. We now express this choice problem mathematically and use calculus to find the optimal bundle. Lisa's objective is to maximize her utility. Capital U of Q sub 1 and Q sub 2 subject to her budget constraint. Max Q sub 1 and Q sub 2 of U of Q sub 1 and Q sub 2. Equation 3.15, and that is subject to S dot T dot capital Y income equals P sub 1 times Q sub 1 plus P sub 2 times Q sub 2. In this mathematical statement of her problem, 3.15, her control variables, those variables that she chooses Q sub 1 and Q sub 2, appear under the max term in the equation. We assume that Lisa has no control over the prices she faces, P sub 1 and P sub 2, or her income, capital Y. This mathematical formulation of the problem asks what bundle or choice of Q sub 1 and Q sub 2 maximizes capital U of Q sub 1 and Q sub 2. Another way of saying maximizing utility given these two choices, given that this bundle lies on the budget constraint, that is, the cost of the bundle equals capital Y. Because this problem is a constraint of maximization, contains the subject to provision, we cannot use the standard unconstrained maximization approach. However, we can transform this problem into an unconstrained problem that we know how to solve. If we know that Lisa buys both goods, which means we are looking for an interior solution, there are at least two approaches we can use: substitution and the Lagrangian method.